We are going to look at inverse functions. In this first problem, they're asking us to find f composed with g of x and g composed with f of x, and then determine whether a pair of functions f and g are inverses. So, in part A, we're going to take function f and we're going to compose it with g. So I'm going to start with function f, writing it down with parentheses in place of the x, and then I'm going to go back and plug function g into the parentheses. So I get x plus 3 divided by 7. And then I will simplify. So if I go ahead and distribute here, I get 3x plus 9 all over 7. And then I have minus 7. And I'm going to think of that as a 7 over 1. And then if I get a common denominator of 7, then I have a 3x plus 9 minus a 49 all over 7. So that becomes a 3x minus 40 divided by 7. Now, when I turn it around and I compose g with f of x, okay, so this is g composed with f of x, that means that I'm going to take function g, write it down with parentheses in place of the x, and then go back and plug function f into function g. So 3x minus 7. And then simplify. So when I take a 3x minus 7 plus a 3 over 7, then I am left with 3x minus 4 over 7. Now, in this case, when they say to determine whether they are inverses of each other, the answer is going to be no. And the way that I know that it's no is because in order to be inverses, when you compose f with g and you compose g with f, not only should they be equal to each other, they should also equal to x in both cases. So if they don't, like I have down here, then the answer is no. Okay, on the second type of problem, they want to know if the graph represents a function that has an inverse. In order for the graph to represent the function or a function that has an inverse, it must pass what's called a horizontal line test. And so what that means is I should be able to draw horizontal lines through all parts of the graph and only cross one point each time. If I'm able to do that, like in this example, then I am going to say yes, the graph does represent a function that has an inverse. So notice on this second example here, if I draw my horizontal line up high, I'm okay. But if I try to draw a horizontal line here, I'm crossing more than 1 point. And if there's anywhere that it crosses more than 1 point, then you have to say no, the graph does not have an inverse function. And then finally, when they tell you to use a graph to draw the graph of the inverse, the easiest way to do that is to identify some points that are on the graph. So notice, for example, I see the point 0, negative 1 that's on the graph they've given me. And then I also see the point that is, it looks like 2, negative 2. It's kind of small, so you might want to enlarge it when you're looking at yours. And so what happens with an inverse is an inverse flips them around. So on my inverse, I should have the point negative 1, 0. So that would put a point over here. And then I also should have the point negative 2, positive 2. And so that would be up here. And so those points get flipped around. And if you look at my possible answers looking for my -1, 0, as well as my -2, 2. The only graph that appears to have those points would be this one here. The other thing you can look at is if you were to fold the graph across the line y = x, then the graph should be a mirror image of the inverse across that line. And so you can see here that this part of the graph is reflected over here, and then you've got this part of the graph that's reflected over there. So that's another thing that you can look at for those inverses.